It is the loneliest object ever made by human hands. Right now, as you read this, it is approximately 24 billion kilometers from Earth. So far that the signal it sends home, a whisper of radio waves traveling at the speed of light, takes over 22 hours to reach us. 22 hours for light to cross the distance between where Voyager 1 is and where we are. And the signal is getting weaker. Not because of distance alone, because the spacecraft itself is dying. Slowly, irreversibly, one system at a time. And the engineers at NASA's Jet Propulsion Laboratory, who have spent their careers keeping it alive, have begun. I was saying out loud what they have known quietly for years. There is no fix coming. There is no rescue mission. There is no version of this story where Voyager 1 comes home. It launched in 1970. It is 47 years old, and it is still out there, still transmitting, still sending data back from a place no human object has ever reached before or since. The boundary region between our solar system and interstellar space, a place we didn't even have a name for when Voyager 1 was built. But the machine is failing, and when it finally goes silent, something will end that cannot be replaced, cannot be rebuilt, and cannot be repeated. Let's start with what Voyager 1 actually is, because most people have a version of it in their heads that undersells its significance. It is not large. The spacecraft itself weighs roughly 722 kilograms, less than a small car. Its onboard computer has approximately 69 kilobytes of memory. A single modern photograph taken on your phone contains more data than Voyager 1's computer can hold in its entirety. It was built with 1970s technology, designed by engineers working with slide rules and early computers, tested with instruments that would be considered primitive by today's standards, and it is the furthest human-made object in existence, not by a small margin. Voyager 2, or its twin, launched 16 days before Voyager 1, but on a slower trajectory, is currently around 20 billion kilometers away. The next closest human object to interstellar space is nowhere near either of them. Voyager 1 has been traveling at roughly 61,000 kilometers per hour for nearly 5 decades, and the gap between it and everything else we have ever built keeps growing. In 1990, Carl Sagan convinced NASA to turn Voyager 1's camera backward one final time before it was shut off permanently to preserve power. From 6 billion kilometers away, it captured a photograph of Earth. In that image, our planet is a single pixel, a pale blue dot, suspended in a beam of scattered sunlight, surrounded by the absolute black of deep space. Sagan described it as a mote of dust suspended in a sunbeam. That image, taken by a machine the size of a small car, built with 1970s technology, running on a nuclear battery that generates roughly the same power as a refrigerator light bulb, remains one of the most important photographs in the history of human civilization. And the machine that took it is dying. The trouble began in November 2023, as engineers at JPL noticed something wrong with Voyager 1's data. The spacecraft was still receiving commands and still responding. The communication link was intact, but the data it was sending back had become garbled, a stream of corrupted numbers that made no sense. The science and engineering readings that Voyager 1 transmits continuously, the data that tells mission controllers the health of every system aboard, had turned to noise. For 5 months, the team at JPL worked the problem. Every solution attempt took weeks just to test. Send a command. Wait 22 hours for it to arrive. Wait another 22 hours for the Or-Saychi to respond to return. A single diagnostic exchange takes nearly 2 days. In April 2024, they found it. One of the 3 onboard computers, the flight data system, had a corrupted chip, a single chip. Roughly 3% of the flight data system's memory had failed. The data it was supposed to process was being routed through that corrupted section and coming out as nonsense on the other end. The fix they devised was elegant and desperate in equal measure. They couldn't repair the chip. It is 24 billion kilometers away, and it is 1977 hardware. So instead, they rewrote the code around it, moved the corrupted section's functions into other parts of the memory, redistributed the load, sent the new software up, as in pieces, because the full update was too large to transmit in a single command. And wait, in April and May of 2024, the Voyager 1 began returning clean data again. The team celebrate briefly, because the chip was not the real problem. The chip was a symptom. The real problem is time, and time is the one thing no amount of engineering brilliance can fix. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs. They work by converting the heat produced by the radioactive decay of plutonium-238 into electricity. No moving parts, no solar panels. At 24 billion kilometers from the sun, sunlight is essentially useless. Just the slow, steady decay of a radioactive element, producing heat, producing power. Year after year, when Voyager 1 launched in 1977, those RTGs were producing approximately 470 watts of electrical power, enough to run the spacecraft systems with margin to spare. Today, they produce around 249 watts, just over half of what they started with. That number will keep falling. Plutonium-238 has a half-life of 87.7 years, meaning it loses roughly 1.4% of its power output every year. The decline is slow. It is also perfectly, mathematically certain. There is no intervention that changes it, no repair that reverses it. The fuel is simply becoming less radioactive with time, as all radioactive materials do, and the air power it produces is declining with it. The engineers at JPL have been managing this decline for years, methodically shutting down systems that are no longer essential to preserve power for the ones that are. The cameras were turned off permanently. In 1990, the pale blue dot photograph was the last image Voyager 1 ever took. Heaters for various instruments have been switched off one by one. Scientific instruments that have completed their primary mission have been powered down to extend the operational life of those still returning data. Currently, 5 science instruments remain active, each one drawing power from a budget that shrinks by roughly 4 watts every year. But the math is not complicated, and it does not end well. NASA estimates that Voyager 1 will no longer have sufficient power to operate any scientific instruments sometime around 2025 to 2026. And the transmitter itself may continue functioning for a few years beyond that, sending a signal that says, in essence, I am still here, before the power drops below the threshold required to maintain even that. After that, silence. A machine that has been speaking to us continuously for nearly 50 years will simply stop. Here is what makes that silence different from any other spacecraft retirement in history. We can build another telescope. We built Webb after Hubble. We can build another Mars rover. We built Perseverance after Curiosity. Curiosity after Opportunity. Opportunity after Sojourner. Turn. We can rebuild, redesign, relaunch. We cannot rebuild what Voyager 1 represents. To reach the position Voyager 1 occupies today, a new spacecraft launched right now, using modern propulsion, modern trajectory planning. Every advantage of 50 years of additional engineering would take approximately 35 years to reach the same distance, and it would arrive at a machine that, by then, would have been silent for 3 decades. There is no shortcut. The solar system is simply that large. The physics simply do not allow for it. And there is something, well, something that rarely gets mentioned in the coverage of Voyager's decline. The data Voyager 1 is sending home right now is irreplaceable in a way that has nothing to do with distance. Voyager 1 crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins, in 2012. And it became the first human object to leave the solar system, not metaphorically, physically. The particles surrounding it are no longer solar wind. They are interstellar medium, the gas and dust between the stars. No other instrument from any space agency, anywhere on Earth, has ever measured that environment directly. Everything we know about what interstellar space actually feels like, the density of particles, the strength of the magnetic field, the behavior of plasma at the boundary of our solar system, comes from Voyager 1, or every model, every theory, every calculation about what lies beyond the heliosphere. All of it is anchored to data from a 722-kilogram machine built with slide rules in the 1970s. When it goes silent, we will lose our only direct connection to interstellar space, not for years, not for decades, for generations. There are people at JPL who have worked on the Voyager mission for their entire careers. Suzanne Dodd has been the Voyager project manager since 2010, and she has spent 15 years nursing a 47-year-old spacecraft through a series of failures that would have ended any other mission long ago. In interviews following the 2023 data crisis, she was careful, measured. The way scientists learn to be when they are describing something that is both professionally significant and personally devastating. She said the team was not giving up, that as long as Voyager 1 was transmitting, they would be listening. What she didn't say, but what the power curve says with complete mathematical certainty, is that the listening will not go on much longer. The engineers who built Voyager 1 have mostly gone now. Some retired, some died. The youngest members of the original design team are in their 70s. The institutional knowledge of how this specific spacecraft was built, the undocumented decisions, the workarounds, the engineering intuitions that never made it into the official manuals exists only in the memories of people who are aging out of the field. When something goes wrong with Voyager 1 now, the team at JPL is often working from 50-year-old documentation, reverse engineering the reasoning of engineers who are no longer available to ask. The corrupted chip fix in 2024 required them to understand the original code, architecture well enough to rewrite it without breaking anything else. Code written before most of the current team members were born. That they managed it at all is remarkable. That they may need to do it again, with a power budget that is smaller every year and a team that has fewer people who remember the original design, is the quiet reality of Voyager's final year. In February 1990, and the day after Voyager 1's camera was turned off forever, Carl Sagan gave a lecture at Cornell University. He had lobbied NASA for years to take that final photograph. He knew it would be the last one. He wanted it taken before the opportunity was gone. He stood in front of the pale blue dot image and said something that has been quoted so many times since that it has lost some of its force. But it is worth sitting with the original weight of it. He said, "Look again at that dot. That's here. That's home. That's us. He was describing a photograph taken by a dying machine at the edge of the solar system. A machine that was already, in 1990, running out of power and shedding systems and moving further from Earth with every passing second. He knew what Voyager 1 was. A vessel that could only go one direction. A message sent into the dark that could never come back. A record of human curiosity, human engineering, and human ambition, launched into interstellar space on a trajectory that will carry it past the nearest star system in roughly 40,000 years. On board is a golden record, encoded with sounds and images from Earth. Music. Greetings in 55 languages. The sound of wind and rain and surf. A mother's first words to a newborn, a child. The brainwave patterns of a young woman in love. It was assembled in 1977 by a committee chaired by Carl Sagan. It was placed on a spacecraft that nobody expected to still be functioning nearly 50 years later. So many times since that it has lost some of its force, but it is worth sitting with the original weight of it. He said, "Look again at that dot. That's here. That's home. That's us." He was describing a photograph taken by a dying machine at the edge of the solar system. A machine that was already, in 1990, running out of power and shedding systems and moving further from Earth with every passing second. He knew what Voyager 1 was. A vessel that could only go one direction. A message sent into the dark that could never come back. A record of human curiosity, human engineering, and human ambition, launched into interstellar space on a trajectory that will carry it past the nearest star system in roughly 40,000 years. On board is a golden record, encoded with sounds and images from Earth. Music. Greetings in 55 languages. The sound of wind and rain and surf. A mother's first words to a newborn, a child. The brainwave patterns of a young woman in love. It was assembled in 1977 by a committee chaired by Carl Sagan. It was placed on a spacecraft that nobody expected to still be functioning nearly 50 years later. And it is still out there, still carrying those sounds, still moving. When Voyager 1 finally goes silent, when the last signal fades below the threshold of detection and the dish antennas of the Deep Space Network stop recording anything from that direction, the golden record will still be traveling through interstellar space, through the gap between stars, through a darkness so profound that it will take 40 millennia to reach our nearest neighbor. It will outlast the signal. It will outlast the mission. It will outlast everything. We are not going to save Voyager 1. And the engineers at JPL know this. The scientists who depend on its data know this. The project managers who have spent careers extending its life by months and years through increasingly creative workarounds know this. The power curve is what it is. The plutonium decays on its own schedule. The hardware fails one component at a time. The distance grows by 1.5 million kilometers every single day. What is left is not rescue. What is left is listening. For as long as there is something to hear. And when the silence finally comes, when the last whisper of a signal from the earth, it will not feel like an ending, like what it is. A farewell to the furthest thing we ever touched. Thanks for watching. I'll see you in the next one.